Okay, hi everybody. Welcome back to 2CM4 Computational Multiphysics, McMaster Engineering Physics. So today, what I'm going to do now is walk you through the general process of what COMSOL looks like. The first thing you're going to do is you're going to open up a new file. Typically, what you'll be doing is be greeted by the model wizard. I'm going to skip that and I'm going to describe the structure of the model file and then welcome you to go back and try and figure out and go through how that model wizard works. COMSOL is largely what I would consider to be modularized or object-oriented, and you'll kind of see that theme emerging. So the general root of your model is going to be your model file. That's going to be your overall big container of all the small things inside it. So my example here is going to be a car engine. And your car engine is going to have a lot of different components to it, but you want to model the overall performance to it. That car engine is going to have certain properties that are common to all of your components. For example, ambient temperature, age, different conditions that you're driving under, time of day, doesn't really matter. All of that is going to go under your global definitions node here. So here there's an option to put in parameters. Here you could say your ambient temperature, you put in your name and expression, and you don't have a problem there. You can also right click and add things like variables. So here the only thing that this node knows about is time. Basically, it won't know anything about physics. We haven't talked about physics. So you're not allowed to put in here anything that depends on temperature, for example, because it doesn't know that temperature exists. Now, inside your engine, you are going to have different parts of your engine or different components of your engine. That's this node here, components. Typically, in most of my models, personally, I only have one component. If you have more components, that's fine. I think you can even mix and match them. Okay? That component is going to be for a particular part of your engine. So if that part is a mechanical part, maybe you're going to have to look at the age of that part, the condition, whether or not it's being corroded. All of those variables and those parameters can go into the definitions node here. Note that it's a bit of a duplicate. This is a more local scope to your coding. That comes into the object-oriented aspect. You can right-click, add variables. You can add functions for more complicated dependencies and things like that. All that goes in here. And now you are aware of the physics. So because your component does have temperature, concentration, fluid flow rate, you can refer to those variables. I'll show you where those come up as. The next thing they need is the geometry. You actually have to draw what it looks like. This is basically going to be very familiar if you've ever used any kind of computer-assisted design, CAD software. You right-click on your geometry. You can select circle, ellipse, rectangle. You can do Boolean operations on that, chamfer, fillet. You can offset. You can parameterize this, do an array of things. We're going to look at one really nice example of a woven carbon fiber that has thermal properties associated with it. You can put it all into the geometry here. This geometry tab can make use of the parameters specified in your global definition. That is the only place where that geometry is able to be parameterized. It has to be up here. It's not for that particular material. The next kind of input properties that you're going to have are your material properties. So here you're going to say something like whatever you would need: thermal conductivity, heat capacity, density, elasticity, viscosity. Put those all into your materials. You can actually right-click and add materials from your library. COMSOL, because of our license, has a fairly comprehensive listing of materials, which is super convenient. The other nice thing about this is that it all has units built in. So if you're putting in definitions as variables, I'll show you how you do it. You put in square brackets and then you put in your units, and it handles all of that dimensional analysis. Thank goodness, to be honest, because otherwise that can be really complicated. Okay, next thing you want to specify is your physics. Each type of physics is in COMSOL as a separate node. So in this case, we only have one type of physics, which is heat transport in solids, i.e. we're looking at conduction. When you expand that little chevron there, now you get the different terms of your Fourier heat transport differential equation. So the first and foremost is going to be your bulk transport, your bulk conductive transport. Here it is. It's the divergence of your heat flux. What do you need to know in order to solve that? Well, you need your thermal conductivity. Hey, look at that. It's down there. It's by name. You can say if you're getting it from the material. I didn't specify a material. So I'm just giving it a value here. That's the example. Similarly, density and heat capacity, our particular example now isn't going to need those two properties, so we just set them to 0. Otherwise, we would set them. Initial value, if you're doing an initial condition, you would want to specify what your initial guess is going to be. And then other properties associated with a model. We're doing cylindrical symmetry, so there is a symmetry plane, a symmetry axis, but because we're displaced from the axis, it's not actually active. So if you go here, it's going to offer to select these boundaries, but none of those are actually applicable. However, we do have insulation. We have insulation. We can click on the different boundaries here. We can specify the temperature on certain boundaries. These are Dirichlet conditions, and the heat flux on other ones. So this is where your physics is specified. Meshing is largely automated. You can typically rely on the inbuilt defaults, but there are some other options that I'll delve into in a separate video. What you want to do is, if it doesn't automatically do it, you want to right click and go to build all, and it'll assemble this nice tessellation for you. Here you can also specify, and you can jump between triangles and quadrilateral rectangles if you want. Okay, so now you've got your component and you know how it behaves. Now you want to know what you want to do with it. Do you want to look at it as a steady state? Do you want to look at it as a time dependent? How do you want to study this component? That is this node, your study node. Here you can study different components, right? Because it's separate from this node. In this particular case, we're setting up a stationary solver. So what you do is you set that step and you build your solver, and this handles it all automatically for you, which is super, super useful. In other videos, we are going to delve into that, and I'm going to break it down a little bit for you now, but you can really rely on that. This is where all the numerical methods are implemented and specified. Okay, the final one is going to be one more thing you have to do. You have to actually run the model. So up until this point, we specified it, we specified the solver, but we haven't actually calculated anything yet. What you can do is right-click on Study It and go to Compute. There's a hotkey, or you hit the button up here on the ribbon, and it does one of these, and off you go. And now you have a solution. By default, it's going to go to the last load, which is your results. So here you're actually visualizing things. It does get a little bit complicated how you're wiring in the solution to that particular visualization. Typically, the defaults are going to be accurate and are going to get you to the right place, but we're going to delve into that in later videos of how to actually do that. So the last thing to do here is to save the file. That's the funny little diskette icon up here. I don't know if you guys remember diskettes or not. You just click save, and I don't want to overwrite the video, so you would want to create a backup. Yes. Okay, and off you go. Thank you very much. Stay tuned for next time.